Number 38 of test series 2 is from water resources. Question is, suppose an irrigable land irrigates both wheat and rice with the aid of reservoir. The basic data are as follows. Serial number, crop, base period, duty at field, and area of crop. This is in days, this is in hectare per cubic, this is in hectare. So the crop is wheat with base period 120 days, 100 hectares per cubic, 2800 hectare area. Then is rice with 110B, 1000 as duty and 3200 hectare as area. The question is, the required reservoir capacity in cubic meter if the canal losses are 18% and reservoir losses are 10%. Is the option A is 6164.20 into 10 to the power 4, B is 6164.20 into 10 to the power 5, C is 6164.2 into 10 to the power 6, and option D is 6.64.2 into 10 to the power 3. Let's come to the solution. We know that delta is given by 8.64 B by D. Okay, and what is delta? Delta is the depth required by the crop. Water depth, actually it's water depth required by crop. So in the whole base period, you can say it's the water depth required or the water depth acquired by the irrigated water. So for wheat delta W is equal to 8.64. What is B? 120 days, and what is D? It is 1700. So it comes out to be 0.61 meters. So volume required by wheat is equal to area into delta W. So area is 2800 into 0.61 hectares. So the value comes out to be 1708 hectare meter. If we convert it into meter cube, this 1 hectare is equal to 10 raised to power 4 square meter. So it comes out to be 1708 into 10 raised to power 4 cubic meters. Similarly, volume required by rice is equal to area into delta of rice. And what is delta of rice? Is equal to 8.64. B is 110 and D is 1000. So 1000. It comes out to be 0.95 meters. So volume required by rice is equal to 0.95 into area, that is 3200, into 10 to the power 4, that is for converting hectare into square meter, and it comes out to be 3040 into 10 to the power 4. So total volume required at the field is equal to VR plus VW. VR is equal to 3040 into 10 to the power 4 plus VW is 1708 into 10 to the power 4, and it is equal to 4748 into 10 to the power 4 cubic meter. Now let's account for the losses. As we know that the reservoir loss is equal to 10%, that is evaporation loss, and then the canal losses in conveyance is 18%. So if VF is the volume required at the field, then we should add 18% of that for canal losses, 18% of VF. Now whatever volume we are getting, we should add 10% of this VF plus 18% of VF to this volume is required for the reservoir, at the reservoir, and since 10% of your reservoir volume is getting evaporated, so total volume required is this much, hence this is equal to total volume required. So V is equal to, what is this, VF plus 0.18 VF and plus 0.1 into VF plus 0.18 VF. It comes out to be 1.298 VF. So 1.298 into VF is 4748 into 10 to the power 4, and it comes out to be 6162.9 into 10 to the power 4. So nearly it is equal to 6.64 into 10 to the power 4 cubic meters. We can do it by another way also. We know that the volume required, the reservoir loss is 10% and the canal loss is 18%. So directly we can get this required volume by multiplying this 1.10, accounting for 10% loss. So we increased that volume by 10% and then multiplying by 18%, that is increment by 18%, and multiplying these two values with VF, we can get directly 1.10 into 1.18 into 4748 into 10 to the power 4, and it comes out to be 6164, nearly 10 to the power 4 cubic meter. Hence option A is the right one.